There is no stress, different stress at this point or this point. It is the same stress, and that is the average stress, that is called membrane stress. Whereas the bending stress is the, now if this is a plate, now I have bent this plate like this. So here, at this point, tensile stress. At this linear distribution through thickness, tensile on one face and compressive on other face. Clear? So you will understand these two categorically. Look, these things is the basic of the design. Ultimately, when you are going to do the design of a cylindrical shell or heads or conical shell, ultimately you are going to use the pressure vessel formulas which is already given in the board. But I want to tell you that from where this has come and what is the philosophy. So this is what I am trying to teach you in this moment. Allowable stress, for such stress is 1.5 times the basic allowable stress. In other words, for this allowable stress has 1.5 times the stress which is given there in the 1.5 times the membrane stress. Stress due to overturning moment over the vessel cross section is membrane and not bending. Now what is the meaning of this sentence? Now, due to wind or due to seismic, there can be a column base goes like this. Due to wind, it will have a force acting in this direction, and the column will have a turning like this. It will bend like this, right? Now, this is a hollow structure. This is a cylindrical shell, right? So, are you with me, or is going a little bit more? So this is a hollow structure. Here, now you will think that at this section, is it the stress which is taking place, is it bending stress or a membrane stress? The answer is membrane and not bending. The answer is membrane and not bending. This is a hollow structure. If it is a solid round bar, solid plate which I have drawn just now, then you bend it. That is outer elongation, that is tensile, inner compression. And here it is not the case. So here it is the membrane stress. And that is what I have stated here. The stress is the membrane and not bending. Strain is change in length per unit, inch per inch, so all very well. Axial stress in the thin cylinder is PR for 2T. Now, basic, very basic thing. You must know well, you know very well, not you must, you know very well. Now, this is a cylindrical shell. Now I will draw specifically two lines here to show the thickness. This is closer. And view of this one. Now, this is called, due to the pressure P, due to the inside pressure P and the diameter D and the thickness T. So, longitudinal stress and here circumferential stress, right? this one. That is the axial stress, longitudinal, that is axial, right? Axial stress in thin cylinder is equal to PR upon 2T, and that is I have specifically mentioned subsea. This is called circumferential seam. And you must have established this formula by using first principle. You must have done. At Nirma, I asked them that somebody should come here and derive this formula from first principle. This is nothing magic. This is not a empirical formula. It is a basic formula. So you should be able to do this. You are not in 12th standard. But you have to apply a little more mind and you will be able to do that. There is nothing, I am not saying something very like this. No, it is not like that. But it is possible. And circumferential stress in thin cylinder shell is equal to PR upon T. So see the difference. PR upon 2T and PR upon 10. Right? So this is PR upon 2T and here PR and this is PR upon T. We have PR upon 2T, the stress. This is half the stress. Right? And this one, longitudinal joint. So we always design pressure vessel for longitudinal joint. In our case, the formula is, look, it is S is equal to PR upon T. Okay, number 1. So can I write T is equal to PR upon S? Number 2. Number 3, there is a weld joint. So there has to be a weld joint. How many defects you have put in the weld joint? Unless you take radiography of that weld joint, your hands, when there is an accident, there is a crack, what you do? First you go to X-ray clinic, take X-ray, then find out there is a crack. Similarly, for industry, for materials, there is a for the joint, weld joint is checked by radiography or by ultrasonic. Both are volumetric examination. That's the full thickness examination is done. Now, if this joint does not show any defect, what can be the defect? In the slag intrusion. Number 2, crack. Number 3, incomplete fusion. Number 4. These are not acceptable defects. But court says there are few defects which are totally not acceptable. Crack, not acceptable. Incompleteness by 3. If it is 25 mm thickness, so 8 mm length, 8 mm practically this one, length of slag is acceptable. Porosity, the globules, they have given the certain chart where they say that for this thickness, this is a small porosity acceptable. Because on the earth, there is nothing is without defect. Whether the plate is not available without defect. There is a defect, but it is within acceptable limit. What is acceptable limit? That specification is spelled out. Similarly, for welding, it is spelled out that this defect is acceptable. If more than this, not acceptable. Okay, so now coming to the point that the joint efficiency is E. When you take full radiography and there are no defects or defects are there within acceptable limit, E is equal to 1. Then when there is you take partial radiography. Now I want to use the spot radiography. Now you have done this welding, you have done this welding, you have done this welding. This is the weld joint, this is the weld joint, and this is the weld joint. In this weld joint, you have welded using the same electrode stick electrodes, SMW, subconductor bending, sheet bending, GTAW, that is GTAW. Gas, inner GP, gas conduction under gas, GTAW. Junction are bending, GTAW. So different bending, but these all drawings 15-meter length, 15 meter. You take only one radiography. If that is okay, in that case they consider that all 15 meter is okay. This is considered as a spot radiography, but for that matter, E is equal to 0.85. E is equal to, this is one spot radiography, E is equal to 0.85 spot, and E is equal to 0.70 no radiography. Don't take radiography, E is equal to 0.70. Okay, now up to here, there is nothing like these formulas are not, this is established from first principle, right? Now ASME has added P is the design pressure, R is the radius, S is the allowable stress. What is allowable stress? Ultimate tensile strength divided by a factor of safety, that is the allowable stress. And I say ultimate tensile strength at the temperature. Suppose the room temperature 485 MPa, then at the 350 degrees centigrade, it 400 MPa divided by 75. So that part, this is little, off, but it is there. So 0.63 is the empirical factor or safety factor headed by ASME. That is the difference. Okay, now this formula is good for longitudinal joint PR upon T. Right?
Work on a off-centric dumbbell type principle. It takes the gas inlet and compresses it, throws it out. So its efficiency is very less. It is used as a backing pump. One slide. For the pumping system, it also always needs a rotary pump to be backed. They cannot pump. They can pump up to its mouth. Below they cannot pump. So they need a backing. Then this root pumps. This is basically dry pump. This is air friction plays a major role in pumping out the air from it. It's same to mm and between the dumbbells and between the dumbbell and the wall. That is what compresses the air and throws it out. This root pump, this is also, in India we don't have any companies which produce. This is like one rotor is knocking out the air molecules, stator is just guiding to the another rotor. So rotor stator combination, they pump out the gas. And this is very efficient process. And in the submolecular level, this pump works fantastically. Then another is diffusion pump. This is oil-based pump. Its mechanism is basically on diffusion process, very fast. In that process, it creates a vacuum on the mouth. That is what is sucking all the air from the vacuum chamber. But this pump needs a vacuum. It cannot pump itself. So these are the things which are being considered for the vacuum industry. These pumps are already available in India and they are successful. But other than that, the high precision pumps, they are not yet successful in India. Then there are the plasma diagnostics. This is basically electrical diagnostics. So what it will do? Anybody can just say? We have charged particles moving. We have a metal inside that charged particle, and we are biasing it with a voltage. So what it will do? Electrical engineering people. What it will do? Please loud, no problem. We have a lot of charged particles moving. That's electrons or ions. I have a metal plate inside. I will bias it with a positive voltage. Positive voltage. What will happen? It will attract electrons. So I can collect the electrons. Okay? So I can collect the electron current. And when it will be biased with a positive current also. So this Langley probe basically does that only. We bias it at a variable potential and can measure the amount of electrons and ions coming to the probe surface per unit area per unit time. That is what is the plasma density there at a given time. Any doubt about that? I want to know the electron density or a particular given time. This area will limit the number of electrons it can take. So that current is my electron cell. Make it a thermal equilibrium with the plasma. Make it with the thermal equilibrium with respect to the plasma. You heat it up, then what will happen? It will not give electrons to the plasma, neither it will take electrons from the plasma because both are at thermal equilibrium. So the potential by giving which I have make that probe to reach the thermal equilibrium, that is nothing but my plasma potential. Because if there are two potentials and they are same, they are not going to interact with each other. So by this technique, we can measure the plasma potential of the plasma. That what potential my plasma is sitting. Now this is a bit engineering because I cannot expose all my electrical connection to the plasma. I have to make it hidden because otherwise plasma. For electrical isolation in the plasma, what materials I can use? Just loud please. What materials? Insulators. I should use some sort of insulators, electrical insulators, high temperature insulators. Huh? No, this has to be mechanical structure. I cannot use the inert gas. Gas can withstand. This is at 2200 degrees Celsius. This probe is burning. So, tungsten is not an insulator. It's burning at a temperature of 2200 degrees Celsius. What kind of insulators I can use? Lead is a metal already. It will be. If I use bricks, the bricks has a lot of porosity. Bricks has a lot of porosity, so it might have a lot of trapped particles inside that. When I heat it up, it will degas. It will deteriorate your vacuum. It will immediately oxidize your probe, and your probe will go. If tungsten get oxidized, we can reuse it. If it is once exposed to the atmosphere and the heated condition, it will immediately go. So any normal insulator will not work because all the insulators they have a limited temperature withstanding capacity. Which one? Paints. The paints will withstand up to how much? 200-300 degrees Celsius. You are at 2200 degrees Celsius. So there are materials like ceramics, specially made ceramics like alumina, Al2O3, that can be used to construct this probe. And one more thing, all the cables in India are available with the central conductor as a copper or a steel. Anything else? Copper, beryllium coated or steel. All the conductors in India, even in abroad also. Now I need to connect a tungsten to the copper. What will happen? And I will heat it also. Copper melting point is 700, 800. It will melt. Tungsten will, I have to take it. When it will heat up? Okay, I am giving you a clue that I can fix it with a copper tube, very tiny tube. The copper wire comes at one end, and my tungsten fixed at the other end. They will fix it up. I will fix. You will fix it with crimping. There is no other way. You cannot braze it. Brazing will go. You have to crimp it, man, brace it, so that by looking at the fact that you don't break in that circuit on the crimping, it is going to burn. So you have to crimp in such a way that there is no resistance developed on that crimp, and it's all mechanical process. You have to do it by hand to do the plasma diagnostic. These are small things we have to take care while doing a diagnostic for plasma particles. So if I want to know the flux, what is the flux, my plasma flux is moving, I can put a loop and record the current. Means if the current is passing through a loop, then it is going to induce a voltage. Then for back calculation, I can know how many number of input into the plasma. But limited to the plasmas with very low temperature. If with a high temperature plasma, I will put this diagnostics, they will simply go. So for high temperature plasmas, we have to move through the technology and we have to adopt some techniques which is non-invasive. That means I don't have to put the diagnostic itself into the plasma, but stay away and post-mortem the plasma, take the information out from the other side. Next slide. So non-invasive diagnostics are mostly optical diagnostics. So they don't interact, they don't disturb, and my optical driver sources like microwave source, my lasers, they are all optical diagnostics. Or my spectrometer, they stay away from the plasma and they emit some rays to the plasma. And what will happen, all those microwave or the laser, they have certain frequencies and they have certain phase. When they interact with the plasma, there is a change in phase, or there is a change in more or less useful for the, not more or less, these diagnostics are must for the fusion gate plasma, the high temperature, high density plasmas, where we cannot put a probe inside. Okay, so this is a magnetic field and the particles are moving like that. It has two scales. One, in a magnetic field it will gyrate. These particles will gyrate with a radius. Second, each gyration has a frequency, at certain frequency. So gyration radius gives me the length scale. At what length?
So as you see here, this is the slide of a photograph of mine and my wife here. So on the top is my wife and below is me here. With, as they say in Gujarati, saas bhi kabhi bahu thi. I also had hair once upon a time. So I also had black beard. So because of all that, I could also manage to get a wife who was very nice and beautiful. But before I talk about my life, how I went to Germany and how I met my wife and what all we did, I would start, why would someone want to go to Germany? And especially the boys, we all like to brag. Bragging is Gujarati mein dumpas, like boasting. So I was born and brought up in Bombay, born to a rich father who had his own industry. And somehow I was of the belief that we don't have to really study to do anything in life. My father was rich, I would study, and sooner or later I would get into his business and become the owner of the business. So I thought that if you have money, you can employ people and they will work for you and they will make money for you. So I was not a very good student and I did not take much interest in study. But for me, the education was only because in Gujarati say, degree hoy to degree madse. Normally, if you don't have a degree, you don't get a degree. So the idea was to get educated so that you can get a good wife and then settle on in life and be a businessman and do whatever you want. So that was one mistake that while I was studying, I was not serious about my studies, did not take studies seriously. And although, fortunately, by the time I finished my studies, my father said, if you think that you're going to get my chair just like that, you are wrong. You have to go and work into the field and that only then you'll be able to get, you have to prove yourself. Only then you become the business. And one request, basically, as I will talk, I will become faster and faster. So if I become too fast and if you are not able to understand me, just raise your hand and I will try to slow down. I don't promise that I will succeed because I think it's a sustainable thing to be in foreign. And then in Gujarati we call it foreign return, PHOREN. So, of course, so I also wanted to go to foreign and I had uncles there, so I kept on telling everyone. And all these girls were tired of my bragging, and they said, yaar, humesha American hi baat kar rahe hai. Even if there is no relevant topics, I will somehow bring an America into it, to impress them. And they were initially impressed, but then afterwards they were also tired. Now, as I told you, because I was not a good student, I could not concentrate on my studies, and I studied in a boys' hostel before. So, never had a chibari, sweet lady, and it was full of girls. So I was always among the girls. There was more with girls than in the classrooms, And then I said, oh God, what do I do now? I said, I have to get out of India, even if I have to go to Bangladesh, because if I don't go, this girls are not going to leave me. So, Germany is the only country in the world which does not require visa for Indians. I'm talking of 70s when there was no visa needed for India to go to Germany. And second thing is the education is free. You don't require to pay any fees. Even now in 2015, education in Germany is free. So I said, okay, if I can study in Germany without any fees, then I don't have to go and take money from my father who was not willing to invest in SSC. Your BSc is our equivalent of SSC. I said, if I have to start anyway to studies, why do I do science again? I can do engineering, and I always wanted to become an engineer, but I couldn't get admission at that time, so now I got admission to engineering. So basically life takes you to a tangent. You plan something, what to tell you is, yes, we should have our dreams, we should wish, but we should be open to what we call fine-tuning in life as it comes. You have to keep on improvising based on the situation. I started to be a good student. So initially I thought I'm a good student because there is no distraction, there are girls there who will distract me. I'm sorry about the girls, but basically yes, girls do play a very big role, positive and negative. I started asking myself, what happened? Why is it that now I'm a better student? And I realized that I was becoming a better student because the education system in Germany was totally different than what is in India. In India at that time, education meant your skill to learn everything by heart. You have to work very hard, stay up the whole night, and have learned all the equations, all the formulas by heart. Retain it, go to your exams, throw it out and you then forget it. And then you get your marks. Whereas in Germany, the education system allowed you to take your books, they allowed you to take your, there was no computer at that time, but they allowed you to take scientific calculators and all. So it was not about memory, it was about understanding of the subject. And this is what I started really enjoying, because basically they would say, okay, in real life also, there will be a problem given to you, and you have to solve it, but you don't have enough time to solve it, so you will be given a small time frame under which you have to solve the problem. And that was fun. It was like a quiz, you know, it was like fixing the big things. So I started enjoying, and I realized that actually Germany was so different than India. While I was in our country, we do not value our culture because we think, oh, we are so backward. Look at America, they are so forward. Good road, good houses, good car, good girls, fast girls, you know, all again. Now all of a sudden, while I was in Germany, I realized that I did not like what I was seeing there. Initially, yes, I like the comfort offered and the opportunity offered. Because young, my mother would ask me, "Beta, khanu khadu?" And I said, "Don't tell me, I'm not a small boy. Don't ask me. I can take care of myself." And then I started missing my mother because there was no one to ask you, "Have you eaten? What have you done? What have you done?" And suddenly, while you are in Germany, people ask you about India, and then they will ask you, "How come you don't eat cow?" On one side, there is so much hunger in India, and on the other side, there are cows on the road. You can slaughter and eat them. Many people think, yes, why not? So I said, there will be the reason, and you start asking, you start reading, and then suddenly you realize that there is a lot of scientific reason behind it. So another change which took place was, besides becoming a good student, I became a good Indian. While I was in India, I was a Westerner. While I was in West, I became Indian. So that was what is called, you find your identity. I realized that I loved my country, I loved my people, and I understood my culture. So I became Indian. And when you become Indian, you also become idealistic. So I also became idealistic. I wanted to do something for my country because I realized that, you know, how come a country like India, which has so much resources, so much talent, so much a big history, a past where we say that we had planes and rockets and weapons, everything more advanced than we have now. I mean, when we talk of Ramayana and Mahabharata, we keep on hearing all those things. But how come suddenly we have lost it? Initially, of course, we blamed it all to the British. So now it is all to the ISI. If anything goes wrong, it is the Pakistani who does wrong, and that time it was all American. Anything happening, Americans do not want to help us make a progress, so we are not making progress. So I became idealistic, and we wanted to do something for the, or I wanted to do something for the world. And luckily, while in Germany, I met my wife. My wife was a Indian origin, a girl of Indian origin. She had come to do a PhD in genetic engineering, and I was very impressed. I said, look, this is a lady who is, and she was a Muslim. And Muslims are more conservative than the Gujaratis are. And in spite of that, she was allowed to go to Germany, be on her own and study. And I was very impressed, and we started, we became friends, and friends we fell in love, and we got married. And she also was very idealistic. She also liked the whole thing, and she said, I want to go with you to India, and I also want to contribute to what you want to do to help our country. And so while, I was a student, I was very active in politics. I became a student leader, and I was in student council. And then, because of I was very strong in politics, they sent me to a conference in Holland where our Prime Minister Rajiv Gandhi was there. And this is where we met him. And when he met us, he was very, very impressed that here is a young couple who is settled in Germany. But as you can imagine, that was the biggest ego massage a young couple can get. That your Prime Minister is telling you, please come to India, and I will need you. So immediately we decided to return to India. There was one more thing which had sort of, as they say to you, sometimes the ideas are planted. It takes its own time to grow. While I was in Germany, while I was studying, initially we thought that India is poor or India is backward because the Western countries do not give us the good technology. They keep all the good technology to themselves and they give us the trash. So I said, we will do something so that when you go back, you don't have to depend on the West. So we will learn the high technology there. And so my wife was doing a PhD in genetic engineering. I was doing my process in environmental engineering. We were good students, and we believed that we can help our country with high technology. And while we were returning, again we made the same mistake what I made, as I told you, which actually kicked me out of India or sent me out of India, dragging. So suddenly now, because your Prime Minister invited you back, so I started dragging again, or we started dragging. It was now it was me and my wife saying, you know what, we are going to go to India and we are going to change India. Our Prime Minister has requested, so India is going to become superpower. Sam Petter has already gone to India, he has made so much difference, now I will go and we'll do something, you know. And most of the people were impressed that here is a young couple who has opportunity to stay here or go to USA, they want to go back and do something for the country, and they are talking from your big names, you know, talking of Prime Minister and this and that. And everyone would say, wow, understand what it was. So we asked what is the appropriate technology. She said, you know what, actually this whole progress which mankind is doing doing farming with hybrid seeds and drip irrigation and mechanization or producing atomic power and all, that's not good for the country. India has to have its own technology which is more suited to its condition. And initially we said, oh, she's a typical German, she does not want us to make progress. She's even elder than us, she was at 80, so there is a generation gap. She had a yoga school. She knew India, she knew Indian culture, she was devoted to this type of work. So was my wife. So we knew that she was a good human being, but we thought maybe she's telling us, but she does not know what she's doing. Require a foreigner to help our country. The only thing you don't have is money. We have no problem. You are our problem. She was very agitated, very angry. And she told me, you know what, I will find out how many problems there are. So she started cutting from newspaper or articles to identify which are the problem areas. And she identified 26 of them. And she says, okay, I cannot solve all the problems.
Good evening to all. I would request to please maintain the decorum of the auditorium.
At least आज तो आवाज होनी चाहिए यार. We are at the end of this event. I want the feedback of this event in just one voice. How was the event? Can't hear. Once again. Thank you friends. So now, first of all, let us introduce ourselves. I am Nawaz Godi. I am from 8th semester Mechanical Department, and my friend and the co-host of the evening.
I am Joy Lakhani. I am also from 8th sem Mechanical Department.
As we all know that we all have been here for SPDC with lots of events, seminars, workshops, and many other things like professional development sessions, etc. etc. We all have enjoyed each and everything, whatever was according to our choice. First of all, I would like to welcome the guests. We have Dr. Curtis from Hong Kong Polytechnic Institute with us, so I would like to welcome him from the whole of our heart. I would like all that please give him a huge round of applause.
We have Madhukar Sharma sir with us, President of ASME India. Put your hands together for him as well.
We also have is Professor S.P. Soni, who is a retired professor of LD Institute. Please give him a huge round of applause.
We also have Professor P.G. Shah, Senior Vice President of Patel's Airtem India Limited. Please give a huge round of applause to him as well. It is still fresh in my mind. When we were
Don't you think
making...
that are we missing something?
Yes?
Guys, are we missing anything? Yes! And what is that? Does he need any introduction? No! So can I get a huge round of applause for this person? Dr. S.P. Charitan, Executive Director of Gandhi Vidyapeeth, as well as Secretary of ASME India section.
The ever scintillating and the most supporting personality. Don't you think he deserves one more round of applause?
हाँ तो कुछ बोल रहा था तू.
That day is still fresh in my mind when we made the proposal for SPDC. And I was not sure that we would get this wonderful opportunity, and here we are hosting the valedictory nearing its end. So what do you think?
No, the same thing is in my mind. I mean the memories, the nights. We did spend I think 2 or 3 nights just for proposal, for framing all the things.
Yes, I do remember that.
That's it. But तब हमने नहीं सोचा था कि such a kind of level we would be able to attain.
We would be able to achieve this level.
We thought that let us give it a try. Now let's see what we do. But fortunately we did it, and I think that we did it good enough, right?
Yes. And it wouldn't have been possible without our coordinators. So huge round of applause for yourself. Let's start with the competitions.
Bas, chalo, sit directly on to the point.
Okay, the first competition is Olga Technical Web Page Competition, and the winner of Olga Technical Web Page is Robin Ranjan from bhgcet. Robin Ranjan will get $200 and also a chance to contest that Robin, meet us in the canteen.
ये $200 की smile है ना?
$1 million smile.
Okay, next we are moving on to the next competition. That is Old Card Technical Poster Competition, and the winner for that is
The winner for Olga Technical Poster Competition is Venkat Naran from CBI. Okay, moving on to the next event, which is Olga Technical Paper Presentation. So I am starting with the runners-up. The fifth runner-up is Kumar Janjala Manoj from CVSA SRAGI.
I would like to request Dr. Curtis to please motivate him with a momento.
A prize money of $25.
The fourth rank.
The fourth rank again goes to Robin Ranjan from bhgcet. I would again request Dr. Curtis to do the honors. Good news, Robin Ranjan submitted his abstract for IMECI, for which he also got selected.
Knowing the level of submitting the abstract as well as getting selected. So once again, I need huge clap for Robin
Not
Ranjan.
a small thing. Actually, he is Einstein of Gadi Vidyapeeth.
$100. Any guesses? Wild guesses from your side?
From bhgcet.
Yeah, it's from bhgcet. That I would announce. No, it's not Hardik, sorry.
No.
तो उसका इतना अच्छा नहीं है.
Hardik का नहीं.
Okay. It is Parma Mayur from B.S. Gandhi College of Engineering. I would like to request Madhukar Sharma to please give him a
Goes to Madhav Modali. Okay, he is also the technical winner for Olga Technical Paper Presentation.
There is also a special prize for the best technical content, and Madhav Modla is the winner for that itself.
He is the technical winner
As well.
as well. You will go with 2 trophies.
Please come back to the stage.
Okay, so now it's the time for first prize. The first prize winner.
रुक भाई, ऐसे थोड़ी हो. चलो, any guesses? नहीं, वो पहले कोई guesses तो बताओ.
It is from BSc.
Okay, it is from bhgcet. Enjoyed it, sir.
बिना guesses के तो हम अनाउंस करने नहीं वाले.
अरे उसका तो बोला ना अच्छा नहीं था.
हार्दिक बहुत नाम करते.
चल ठीक है, सब बोल रहे हैं तो हार्दिक रेफरी अपनी तरफ से.
Happy Saturday is getting a chance to practice at IMECI using testing.
This topic was innovative water saving. What? तो कैसे बने मेरे को पता है, साथ में ही रहते हैं मतलब। आपसे ही सीखा था। अरे वाह, thank you everyone. After that, we are moving for SDC. As you all know that what is SDC. This time the theme was robot relief, robots for relief, and it was a great competition. पूरा दिन civil building में, it was a huge crowd. जाना भी मुश्किल था वहाँ पे. But unfortunately, total there were 22 teams who have registered themselves, but no team was able to complete the task, and unfortunately no team has been qualified for the competition. I mean, there are no winners and no runners up in that. But apart from that, yes, we have two special categories for that, so we would be awarding them this special categories. First category, Joy would tell.
Okay, the first category is Best Use of Advanced Manufacturing, and the prize goes to Rahat team from IIT Madras.
The claps are not enough.
The participants of predictive design and simulation tools, and the prize goes once again to IIT Madras. The team name, okay, the participants' name are Manish Prajapati, Sai Gole, Rohit John, and Sarar V. The prizes.
It's a great thing to know that both.
Very interactive session with 2-3 representatives from each colleges. Rather, we had a brainstorming session with all of them. We ignited their intellectual minds. For more, I would request Piyush Gupta to elaborate for the same.
Gupta from IT Roorkee, and I'm currently the zonal representative of Zone 2. So, just before announcing the names of the zonal representative of this year, I'd like to discuss some of the points that we discussed in the meetings that we held yesterday as well as today. The thing is, ASME is providing a platform for everybody, for all the students. It's not limited to the mechanical engineering students. It's having a multidisciplinary approach. So we are thinking of engaging the industrial experts. We are thinking of having an industrial problem statement this year and have relations with them and think of internships. ASME is providing internships for the students this year. Okay, so I like the ZRs for this year to really work on this approach. Secondly, the competitions and the events that we organize. We have one competition like HPDC, and then we have a great event like SPDC this year. We are thinking of converting them into zonal events. So I request all the ZRs that are going to be elected to concentrate on converting these at the central level to the zonal level. Okay, so this way we will be getting more and more student sections will be engaged in the ASME, as well as we'll get more and more participants. Apart from the participants, like this year, no SDC team could qualify for the IME, but no problem. In the zonal events, this problem will be eradicated and all the quality participation will be there. Okay, I hope the ZRs for this year will be putting their 100% effort in this, and I hope it will be a really great success. Thank you. So I'm going to announce the zonal representatives, and you can come up on the stage. For the zone 1, it's Abhishek GR from IIT Roorkee College. Zones in India, but we haven't decided the zonal representatives for all the zones. Only those have been selected who are really deserving and they actually have this belief to promote ASME and really perform their work. So, depending on the dedication, we have selected the zonal representative after a long process. For zone 1, we have Abhishek GR from IIT Roorkee College. For zone 3, we have Mohit Gandhi from DTU, Delhi Technological University. come up on the stage. Right? Abhishek and Mohit. Then for the zone 6, we have Rohit Solanki from bhgcet. There were total 7 people we thought who were deserving, and since there were more than 1 applications for the same, Amandeep Goyal from NMIMS University Shirpur. He is elected as the deputy zonal representative of ASME. Similarly, for the zone 7, Abhiram Madhavapedi from Chaitanya Bharati Institute of Technology has been selected as the deputy zonal representative. Okay, I hope you guys will be really working and putting 100% effort as we did in this SPDC. You can see the effect in this SPDC. I hope the SPDC 2016 will be a great success, and I hope you will be enhancing ASME to the best possible level that you can achieve. Okay, then thank you guys.
This newly selected intellectual minds to collect the contact numbers of those who were present in yesterday's meeting, the most intellectual and the most enthusiastic minds from Professor Sujata Vadwa later. Please collect the contacts from her, and please be in touch and keep contact with them.
Now, this event couldn't be a success without the judges. The judges who have judged the events wisely, fairly. They have spent a lot of the time behind this thing. So how could we forget wishing them? How could we forget without giving them a token of love?
Very true, Nawaz. Actually, any event cannot survive without judges. Any competition cannot survive without judges. So we would love to honor our judges, beginning with Professor S.B. Soni. I would request Nawaz Ghori to give away the memento to Professor S.B. Soni. Nawaz, please. Please, I would like to give away the memento to Parthiv Jani. It's time to judge your competition. Get it more, please.
To invite Maitri Rana, who is the current chair of bhgcet student section, to give away a memento to Professor Amit Ved. He has also judged an event and he has spent his time for us. After that, I would invite Joy itself to give memento to Mr. Barkha Jasani, project manager in Expert Solutions Private Limited. Is he over here? After that, I would like to request Joy to give away a memento to Professor Amit Sada. Sir, please come on the stage. After that, I would like to invite Darshan Joshi to come on the stage to give away a memento to Professor Shushri Bhatt. She is from Mechanical Department itself. Okay, as well as paper presentation as well, and I would like to invite her favorite student Joy to do the honors for her. Joy, please, madam, please come on the stage. The judges. Now we have some dynamic personalities who have already been the judges, as well as we have got some special help, special attraction from them. They are the backbone of our college, institute, as well as ASME, we can say that. Yes. So starting with that, we have a special category for them. First and the foremost, I would like to invite Professor Amit Sada to please come on the stage and give a memento to Mr. Madhukar Sharma, who is the president of ASME India.